Welcome back. This is our Algebra 2 sequence and series, lesson number 5, geometric series, homework review, part 3. Please make sure you catch parts 1 and 2. And definitely, if you find the video helpful, please give it a like, hit that like button. And if you have not subscribed already, please subscribe to the channel and turn on notifications to be alerted when new videos are added. So question number 4. Which of the following represents the value of, in this case, summation from I equals 0 to 8 of 256 times 3/2 raised to the first power. Say the rest of raised to I power. Well, the way the summation works is that you would be plugging in this first number 0 in for I. And so the first of the sum would be 256 times 3 over 2 raised to 0 power, and then plus 256. Next number would be for 3/2 to the first power, and we would add all the way to 256 times 3/2 to the 8th power. That would be the last number here. So to find the sum, we see in this case our first term really ends up becoming a1 equals 256 because a number to 0 power is equal to 1, 3/2 to 0 power is 1, times 256 is 256. We know in this case our R value is 3 over 2 because we're in each situation we're multiplying by 3 over 2 every single time. And so that's our R value. So R is equal to 3 over 2. Now, the question is going to be how many terms? It looks like 8 terms, but if we start at 0, like in this case, if we had this here, it starts off with the exponent being 1, and here the exponent being 8. So just from those 1, 2, 3, 4, 5, 6, 7, 8, there's 8 terms. But we also have a 0 term here. So the end value number of terms has to be 9. And so we have here the formula, all right, we use our S of 9 terms, is equal to A1, which is 256, times 1 minus parenthesis 3 over 2, close parenthesis, to the 9th power, close parenthesis, all over, parenthesis, 1 minus parenthesis 3 over 2. So again, if you write this in a calculator, 256 times 1 minus open parenthesis, 3 divided by 2, close parenthesis, raise the 9th, close parenthesis, divide by parenthesis, 1 minus parenthesis, 3 over 2, close parenthesis twice. Okay? All right, so let's enter this in. We have, in this case, 256 times 1 minus, open parenthesis, 3 divided by 2, close parenthesis, raised to the 9th power. Remember, not the 8th power, but the 9th power. We found that because there are 9 terms altogether in this geometric sequence. Series. Divide by, open parenthesis, oops. I'll just overstrike this one, open parenthesis, 1 minus, open parenthesis, 3 divided by 2, close parenthesis again. All right, and so now we enter and we get 19,171. That will be our sum. 19,171, which will match up to our choice number 1. Okay? And yes, super important that we use 9 terms instead of 8 terms. Okay. That was question number 4. Now for question number 5. A geometric series whose first term is 3 and whose common ratio is 4 sums to 4,095. The number of terms in this sum is going to be, well, sorry. So what happens is we use our formula here. S of n is equal to A1 times 1 minus r to the nth power all over 1 minus r. And we're looking for the n value. So we don't have to use our nth term here. We just, we know here our sum is 4,095. So our equation will be 4,095 equals our first term is going to be 3 times 1 minus our common ratio is 4 to the nth power all over 1 minus 4. Okay, because again, r is 4. We don't know what n is equal to. Well, we can do a couple of things here, because this can will turn out to be 4095 equals 3 times 1 minus 4 to nth power all over, now 1 minus 4 is negative 3. And the negative 3 and the positive we divide out here, and we're left with a negative 1 on top. So now we have 4095 equals negative 1 times 1 minus 4 to the nth power. Well, we'll divide both sides by negative 1. And we're going to get, in this case, negative 4095 is equal to 1 minus 4 to the nth power. Just continue, subtract 1 on both sides, and we're going to get, in this case, negative 4096 equals negative 4 to the nth power. Now comes the important part to understand. The negative 4 to the nth power does not mean it's negative 4 times negative 4 times negative 4 n times. This really means, and I want to be very clear about this, negative 4 to the nth power does not equal to negative 4 to the nth power. Instead, negative 4 to the nth power is equal to negative 1 times 4 to the nth power. So with that in mind, I'll divide both sides by, oops, sorry about that. Just gotta bring this up here. Maybe take this out a little bit here. Let me just edit this here. Okay. Thanks, computer, for not working with me. I'll just take these out here and then just erase them. This way I don't lose anything here. Okay, so we're gonna divide everything by negative 1. Now we have 4096 equals 4 to the nth power. Now, what we could do in this case, we could kind of guess and check here, all right, with our calculator. We want to see, in this case, we're going back here, we have choices of 4, 5, 6, and 8. Which one, 4 to what power of these will equal to 4096? Okay, so let's go to calculator here. So 4 raised to the 5th power, that's equal to 1024, too small. 4 raised to the 6th power, 4096, there you go. So that's the number we're looking for. So we see in this case, 4 to the 6 equals 4096. Therefore, the nth term will be 6. That's what we're looking for. I have n terms here. Okay? Next entire page. Okay. Now for number 6. Find the sum of the geometric series shown below. Show the work that leads to your answer. Okay. Well, it's geometric, so we need to find the common ratio. So we take a2 over a1, which is really going to be 9 over 27, which is 1/3. So that's our r value. Okay. Our a1 value is 27. And now we got to figure out, all right, the nth term. Well, we use a sub n is equal to a1 times r raised to n minus 1. Because we know the final term will be 1 over 729. So that's 1 over 729 is equal to 27 times 1/3 to the n minus 1 power. Well, we're going to divide both sides by 27. All right, so divide both sides by 27. So we'll show in this case that here we'll do 1 over 27, 1 divided by 20, 1 over 729, I believe it was. 1 divided by 729. And we divide that by 27. We get this decimal here, of which we'll just hit math, enter, enter. Oh, unfortunately, it's not helping us out. But wait a minute, though. We also know in this case that 1 over 729 divided by 27 is the same thing as 1 over 729 times 1 over 27. So here we'll have 729 times 27. Our denominator will be 19,683. So notice I would take 1 divided by this number of 19,683. We get the same exact answer as this one. So we're going to write down as this crazy number here, all right? And you'll see we're going to make some changes here too. You'll see why I wrote down this way. So 1 over 19,683. So we have 1 over 19,863 is equal to 1/3 raised to the n minus 1, which we will express as, remember when we divide by, when we are raising a power to n minus 1, this is the same thing as writing out 1 over 19,863 is equal to 1/3 to the nth power divided by 1/3. So now what I want to do is I want to get rid of this denominator here, and we're going to, in this case, we're gonna multiply both sides by 1/3, all right? To get rid of our denominator here of 1/3 on the right side. So here we're going to get left with now 3 times 19,863. Okay, so 3 times 19,683, so 683. Means we have 59,049, all right? So 1 over 59,049. Oh, this is so nutty. 1 over 59,049 is equal to 1/3 to the nth power. Now you'll notice in this case, I'll multiply 1/3, 1/3, 1/3 over again. The numerator says 1, so the denominator is a power of 3. So what we have to figure out in this case is going to be 3 to what power will equal to 59,049. Well, again, we can kind of guesstimate here. So 3 to what power equals 59,000. So we'll take 3 and we'll raise it to, let's start off with 10. Oh my goodness, look at that. It worked out perfectly. All right, so n is equal to 10. Now, just to be like you're saying, well, how can I do this without this? No, is there some type of formula? You could take the log of both sides. All right, you could take the log of both sides, and you, in this case, you would end up getting 10 as your answer anyway. So n equals 10. So there you go. So now we want to find our sum. So the sum, because that was originally what we're looking for, right? So the sum of, in this case, n is 10, is equal to a1, which is 27, times 1 minus parenthesis 1/3, close parenthesis 10th power, close parenthesis, all divided by 1 minus parenthesis 1/3. And so enters our calculator, 27, open parenthesis, 1 minus parenthesis 1 divided by 3, close parenthesis, raised to the 10th power, close parenthesis, divide by, open parenthesis, 1 minus open parenthesis 1 divided by 3, close parenthesis twice, and we get, 40.499. Okay, so let's hit this math button, math, enter, enter, and we get 29,524 over 729. Such a crazy number. So we get 29,524 over 729. Okay, ladies and gentlemen, this is it for our video. Thanks for watching.